Hey, physics class! Galen here. In the Star Wars series of movies, the Jedi are able to use a power known as the Force to move things around with their minds and to see into the future. But of course, the Force is pure fiction. Or is it? Clearly we can't use our minds to give ourselves superhuman abilities, but the idea that two things can influence each other without anything connecting them is a real thing. For all of human history, we've been trying to quantify the world around us. Wind, electromagnetism, gravity, all these things are things that we had no idea what caused them. Now we easily understand today. Even gravity is just the contraction of space-time, not an unknown invisible force. But there's one field of physics that makes people question our view of a quantifiable universe, and that's quantum mechanics.
It's a bit misleading to say that we don't understand quantum physics though, because the quantum world is one of the most studied and understood fields of physics. We understand a lot of the math and models that describe these phenomena, but what we don't understand is why all of this happens. Strange things happen on the quantum scale that are counterintuitive to our understanding of macroscopic physics. We are used to the models of particles like electrons being little physical balls, but in quantum mechanics they're most often described as a wave. Just like what we saw with the double slit experiment, when you fire electrons through two slits in a wall, instead of creating two distinct lines where the electrons hit, you see a series of lines which corresponds to the interference pattern of the wave. The model of an electron as a wave is known as the wave function. If you square the amplitude of the wave function, you get the probability distribution, which describes the probability of finding the electron at a certain position. If you look closely, this looks similar to the pattern from the double slit experiment.
Unfortunately, we don't know if the wave function is actually real or just a mathematical model. Nobody's ever seen a wave function experimentally because as soon as you take a measurement of the system, the wave immediately collapses into one of the many probabilities. This is what's known as superposition, the idea that a single particle can be in two places at the same time. This is what gives quantum mechanics its fame as a spooky and hard to understand topic. As you can probably tell, this is a very strange view of the universe. It tells us that nothing can be predicted with 100% accuracy because the universe is fundamentally random. This was a departure from classical Newtonian physics and made one such physicist, Albert Einstein, somewhat uncomfortable. Quote, "God does not play dice."
Entanglement is what happens when two wave functions interact with each other. When they interact, they basically combine to form one big wave function that describes both waves, and by extension, both particles. Because of superposition, the act of observing one of the particles will also immediately create a change in the other particle, since they are now described by the same wave function. This happens regardless of the distance between the two particles. This implies some form of faster-than-light communication between the two particles, but in truth, we don't actually know if these are two separate particles or a single wave. So how can these invisible connections be used to our advantage? One of the most promising areas is in quantum computing. Normal computers work by using bits, which can represent either a 0 or a 1. But a quantum computer uses quantum bits, otherwise known as qubits. A qubit, due to the superposition state of the particle, can represent both a 0 and a 1 at the same time. This makes quantum computers exponentially more powerful than regular computers. Other potential uses of quantum mechanics are security, communication, and even teleportation.
So if you're ever sad that the Force isn't real, just remember that we have our own version that's even more inexplicable. And as always, thanks for watching.